Welcome to the next talk, which will be by Holger Levsen about reproducible builds. Give him a very warm applause.
Thank you, Rhonda. Good morning. Thanks for coming. I'll talk about reproducible builds, the first 11 years and beyond. This is from DebConf 13. Luna started above. I'll get to this in a second. So I'm a pretty old Debian user. I love Debian, done a lot of work. Since 2014, I'm focusing on reproducible builds for Debian, but I actually want to make all free software reproducible. Ask me anything, anytime during the next days. This is a pretty complex topic. Please come to me anytime. That's fine. So, reproducible builds. These are the people have been working on this according to my knowledge, but not only we have them on the web page. There are many names there, so this is not my talk, but a talk of 100 people, basically, or more. So who knows about reproducible builds, why and how? One person, two, three, okay, some. Who contributed, or is contributing? A few shy people early in the morning. Who knows reproducible builds have been around for more than 10 or 11 years? I've gave some talks, so maybe you get the mailing list. For 30 years. Like, reproducible builds are really old. Who knows about SBOM, the software builds of material? That's basically what we defined as build info files in 2014. So I'll explain SBOM a bit later. And we really need you, everyone, because it's a shared effort, and we cannot fix all the packages. We need your contribution. And in this talk, I'll try to both celebrate what we've done and try to make you excited to contribute. Because there's still a lot of work to do, even if we are quite far. And I think it's doable, and we can do it together. That's really like Debian. So an introduction for those who don't know it yet. The problem, source code of free software is available, but most people install pre-compiled binaries. And no one really knows how they really correspond, even those building the binaries. They might be the same, but your machine might be backdoored or whatever. And usually you don't build yourself. You get the software from somebody, and they say this binary comes from this source, but you don't really know. So 10 years ago, there was an idea on the Debian Devil mailing list to suggest this. I think it would be really cool if Debian policy required that packages could be rebuilt bit identical from source. At the moment, it is impossible to independently verify the integrity of Debian binary packages. That was in 2007. And then, why? I see no benefit. Or, I don't think it's technically infeasible. But hey, I'm happy to be proved wrong. And so the idea even popped up earlier in 2000. And then in 2017, while we already worked for a few years on it, we learned from John Gilmore, who was involved in GCC in the 90s, that GCC and the 202 chain was reproducible on several architectures. But that bit rotted and wasn't that case anymore. And then fast forward to last year, there was a mail on the WireGuard mailing list where the WireGuard people said, hey, our VPN app for Android is reproducible in the Google Play Store on their website on F-Droid. And they didn't even inform us. They just posted it on their mailing list because this is how things are done by some people now. That was really great. I was really happy when I learned about this, that they didn't inform us, because that's what you do nowadays. So we have a definition on our webpage which describes when is a build reproducible. A build is reproducible if given the same source code, build environment, and build instructions. Any party can recreate bit-by-bit identical copies of all specified artifact. That's our definition, what is a reproducible builds. And there's also the relevant attributes of the build environment, the build instructions, and the source code are the inputs. And then there are expected artifacts, that's the output. And this is how we define reproducible builds. And our mission is to enable anyone to independently verify that a given source code produces bit-by-bit identical results. We don't want that Debian says the software is reproducible. Each of you should be able to also independently confirm this. And reproducible builds are just an important building block in making supply chains more secure. Nothing more, nothing less. If the software is insecure, it will stay insecure. But with reproducible builds, you can ensure that you run the software which you mean to be running. So, and this is from 2014. So we've had this for a long time already. And I mix up the slides. So we have the resources, we have publications, all this is documented on our webpage. And in 2021, the White House mentioned reproducible builds for the first time in a bulletin as part of making supply chains more secure. So it's not only been understood by us, but by many. And they mandate the software bill of materials, this SBOM thing, so that they know what is the software made of. So how did we get there? With money. Money was a main factor. And Edward Snowden. Why money? Bitcoin. Bitcoin, the software, was made reproducible in 2011, so before Debian started, because at that time all Bitcoins in the world were worth 4 billion, and the developers were really afraid if there was some backdoored binary and that would steal the money and they would be accused of having this, so they made their source reproducible, and that was amazing. And Snowden, why Snowden? Well, the Tor browser was made reproducible in 2013 by Mike Perry, because Tor browser is a privacy-aware software, and they also wanted to be sure that there's no backdoor, that there cannot be spying. And Tor browser is Firefox, one of the biggest softwares in the world. It's a 50 or something megabyte binary, and each bit was identical. And that was quite new then. So yeah, this is how we got there. And then the work of many people over many years. So in 2013, Luna started a brainstorming session inspired by the success of Tor browser. And then we had another BOF at DebConf 14. So this is what I showed you in the beginning. That was the kickoff thing. There were 30 people here. Was anybody in the room there? No one. Me neither. I was doing video work, I think. And then there was this talk by Luna at FOSDEM 2014, which was in the Debian dev room. And then we had the first patches for dpackage, and which made the sorting order before the elements of a Debian package were not sorted correctly. And we invented build info files. The build info files record the environment so that you can, the build info files have the environment and the sources and the hashes of the build binaries. So this is all 10 years old already. And then in September 2014, I started systematic builds of Debian package. First just 100 packages in a for loop, and then all of them. And Mike Perry and Seth Schoen from the Tor project gave a presentation at the CCC Congress in December 2014, and they showed my graph. I was sitting in the audience and I thought, wow, I'll show you something from the talk now. So this is the talk, some slides from the talks in 2014. I want to believe because the only proof that the binary package comes from is that somebody says so. Whether it's Debian or Microsoft or Google or your brother, somebody says this this binary comes from the source. But that is not really good. And I'm a developer. I built the software myself. I'm a careful, responsible individual. Why should I have to worry about the risk of the contents of my binaries? I built them on my computer. We think of software development as a binning activity. I'm not that interesting. Who's using my software? But attackers target people by targeting the supply chain or the project. And there have been attacks against infrastructure, against Linux, FreeBSD, the XZ disaster this year with Debian. And there are compromises which are extremely hard to detect, extremely possible, and extremely harmful. And imagine the most secure computer in the world. Is it networked? Can it be accessed by others? Is there hardware accessed? Does it run whatever, unauthenticated HTML, JavaScript? Nation state wants to access it. Can you really protect it? And if compromising one computer gives you access to 100 millions of computers, every bank account, every Windows computer, and also how much money you can get, and how much money can be used to attack your computer. I became aware of this in 2014 when I was working on Debian LTS and built kernel for LTS and did binary uploads of this kernel, and they were built on my machine, and I knew, millions of people run it, so suddenly this computer is a very high valuable target. And how small can a backdoor be? That was a CVE against OpenSSH in 2002, and the error was that the comparison was just greater, and it should have been greater equal, and the diff is 1 bit in the binary. So this is the assembler code, and the difference is 1 single bit in a 500 kilobyte binary, I think. There it is. Can you see it? Will you notice it? And not me, but Mike Perry or Sachin created a kernel module that modifies C source code if accessed by the compiler, but not if it's accessed by an editor. So you look at it, the source code is fine, and when the compiler builds it, it's wrong. No files on disk are modified, so it's hard to detect. And this is the graph they showed. The green part is Debian packages which are reproducible, the orange ones are unreproducible, and the red ones fail to build. And the graph, you probably cannot start it in October 2014, and it ends in January 2015, so this is just the first 3 months. And then 2015, Luna and myself made a talk at FOSDEM again, and invited the whole free software world to collaborate and tackle this problem. Because we realized it's better if not all Debian works on it, but every project, because it's usually many upstream problems as well. And Luna gave a presentation at the CCC camp showing many problems and their solutions, which is still a good talk if you want to get an idea what problems there are and how to fix them. And we had the first summit in Athens. I'll get to this in a second. We developed a spec, source date epoch, also explain this, and we wrote diffoscope. Luna started it as DebBindiff was the name here. And DebBindiff was Debian specific, so it was renamed to diffoscope. But first, the common reason for unreproducibilities is timestamps. Timestamps and timestamps and timestamps. And more timestamps. Software likes timestamps. And build passes. And for timestamps, we'll tackle with source date epoch, and build pass, we just say, just rebuild in the same path. We record the build environment, the build pass is part of the environment, and that is fine. We tried for many years to also build independent of the build path, but by now we've decided the build path is part of the environment, and that's fine. And all the rest. And the rest are many issues. So who knows about source state epoch? Every Debian package uses source state epoch now, so you don't have to know it. It's great. Like, not many people just raise their hands. So build timestamps are largely meaningless. Source state epoch describes the timestamp of the last modification of the source in seconds since the Unix epoch. And that is supported by lots of software. If source date epoch is set, then that will be used instead of the current date. Like documentation used to have, or other things like this software was built on this date, but the build date is meaningless, so it now shows this source was last modified. And there's lots of documentation packages, GCC, Clang, Python, OCaml, whatever, they all support source date epoch today. And it made this spec in 2015, made a small edition in 2017, and since then it's unchanged. So and the spec is 2 kilobytes text, pretty short. And of course it's online. So diffoscope, who knows about diffoscope? More people. Diffoscope is really great. Who uses diffoscope? So diffoscope tries to get to the bottom of what make files directories different. It will recursively unpack archives of many kinds and transform various binary formats into more human-readable form to compare them. So in the Debian case, you have a deb archive, which consists of an R archive, and in the R archive are 2 tar archives, and in the tar archive is maybe a PDF, and the PDF contains a PNG image, and the PNG image has different timestamp. Diffoscope will show that, and just this timestamp. And so it has text and HTML output, and it supports many file formats. And this is like a year old. There's probably 20 or more file formats added since then. It supports ISO images. So in the beginning, you could only compare to deb archives, but now you can point it to directories, to ISO images, to anything, and it will compare it. And it's also been useful outside software development. I have met a lawyer who likes to compare laws. He has PDFs of the law, and if he compares them, that doesn't work, but diffoscope will nicely show which text parts have changed in the PDF. And if it cannot pass, the file will fail back to hexdump comparison. It does fuzzy matching, and it does a lot of things. You should really give it a try if you haven't. I have some example output here now. This is the one link I need to press. So this is, on the left there is HTTPS everywhere 506, on the right is 507, and the differences are shown here. So you can also use it to compare 2 different software versions to see what are the changes between 2 versions. So there's many use cases for diffoscope. How do I go back? And you don't have to install diffoscope. You can just try it online and upload some files. Installing diffoscope, if you install it with all the recommends, is about 1.5 gigabyte to support all these file formats. So you can try it online too. And it's on its web page. So this is the graph. Oh, this is a different graph. This is the graph of bugs we fixed over the last 10 years. And this is the reproducible bugs we fixed. So we almost fixed 4,000 bugs. Mostly upstream them. The green ones are fixed bugs, and the red ones are still open ones. So there's still 300 bugs lingering in the BTS where maintainers can apply them. We would also like more bin NM use. And we categorized the issues, and besides timestamps and build paths, we also found 430 other issues. So it's not only timestamps, there's some other issues as well. And this is explained in Luna's talk very well. And then it's often people ask, what can I do to make a package reproducible? And that's hard to say. It's easier to say what makes packages unreproducible. Like if you don't sort them correctly or other stuff. So we made an unreproducible package which has lots of problems. And we found more bugs, like because we constantly rebuild, we find lots of fails to build from source bug in Debian. Almost 9 per day over the last 11 years, because people use our rebuilds all the time. And we found more benefits from reproducible builds we didn't expect. Because if the results are largely the same, you can cache way better, the compilers can cache better, and so you have less development time. That's some reason why many big companies also want it, because it saves money. And you can see whether this change has only the effect on this binary and not any other. And license compliance. You can only be sure that a binary is free software if you know that this binary comes from the source. And the SBOM files we have are reproducible verified. Else the SBOM files are just a statement saying this should be included. With reproducible builds, you know that is really included. We made some summits over the years, like we had 8 summits so far, 7. And there were many projects. That's not only Debian, there's MacPort, Mirage OS, NetBSD, Fedora was there, Apache, whatever. There's more projects which didn't want to be named. And we found more benefits of reproducible builds. At the summit in 2016, some people thought, can't we bootstrap the software and build from source and not use any binaries? Like when you build from source Debian, you always use binaries. And so they come now that they started from a very small, it's now 500, I think it's less than 500 bytes machine code, which can build a tiny CC, or an even smaller CC1 or CC0, that builds CC1, that builds tiny CC, that builds GCC. And then they can bootstrap whatever, Java or anything else. And this is really coming from 500 bytes binary. We'll have a summit this year. Again, it will be in Hamburg in September. We want you, if you want to attend, please talk to me or Mattia. We would also like to see sponsors for this, which brings me to funding. The Reproducible Builds project is funded as a Software Freedom Conservancy project since 2018. It's funding Chris Lamb, Vagrant, and Mattia Rizzolo, who's also sitting there. And that's for supporting our work. And our current sponsors are CIP, OTF, and STF. And we had a lot of past sponsors too, which really enabled this work also. So about the status in Debian. These are the CI results for Debian unstable. What I showed in the beginning is just till here. This was the first graph, ended there. So this is 11 years past. And you can see Debian is almost twice as big today. And Debian is a lot more reproducible now. And I think, no, let's do this. This is again the old graph. And these are the numbers. And the interesting part are the unreproducible packages. I go back so you can read them better. So it's now 700 source packages are only unreproducible. And 34,000 are reproducible. And this is Trixie, which is reproducible since the beginning because Trixie is so young. And since the end of last year, the reproducible builds results are shown in the testing migration pages. And the release team wants to introduce penalties for forky, for violating if packages regress. So if they have been reproducible and suddenly are not anymore, then the migration will take longer. That's the idea currently. And new packages must be reproducible, else they cannot enter testing. This is what the release team and what we would want for next year. And of course, we can whitelist some packages, because if the kernel or whatever LibreOffice is not reproducible, we still want LibreOffice and the kernel unstable. And so policy. In 2017, policy was amended that packages should build reproducible. It's not a must, it's a should. It's a normal bug if it's not. And we want to change policy next year that packages must not regress. And new packages must be reproducible. And then maybe in 3 years, all packages must be reproducible, except the whitelist stuff. And 100% is a technical thing, but it's not really technical. It's a political decision, because policy is said. And we need to change Debian policy. And whitelists are fine. I hope to get this done by 2027, so it's still a bit time. And penalizing testing migration is just a means to enforce policy, but it can be done before we change policy. So what I would like to see is Trixie that maybe has 256 unreproducible packages. Forky then will only have something like hundreds, but no more regressions, no new packages. Forky plus 1, which is whatever, 2029, has only some policy violations which we whitelist, which are fine. And Forky plus 2 in 2031 or whatever, when it will be, maybe or hopefully will have 0 unreproducible packages. That's the timeline I'm hoping for or aiming for. And what they did in last year is based on our CI results. At the moment, we build packages twice in the same environment. And so they have this testing migration. But what we really want is to compare against what we build, what Debian distributes on FTP Debian.org. And for that, we need snapshot Debian.org to be able to get these packages. And snapshot was a long time broken, but it seems we can do this now. I'm not sure whether you realized that snapshot was not working well. It was fixed like the last months. And so I show you the slide from earlier. We had these rebuilder results, but it was broken because snapshot was not functional. I'll get a bit. Because for rebuilding, we need the old version. And we couldn't get them all from snapshot. Snapshot would not scale. There were many bugs, and most of them has been fixed in the last months. And now we can recreate the same environment which was used 5 years ago. And we have been stuck here for 5 years. So that's why we only had CI builds and not rebuilders. And I think the snapshot is fixed. We should do a proper announcement for this. Of course, it's new and it's summer and pre-DebConf, but... So now you can use debootsnap, or you can use deb rebuild, which you will use debootsnap, which are part of the dev scripts package and unstable. Both tools probably very few people have heard about them. I think there were 3 users of deb rebuild. So you fetch a build info file from the build info server, and then you run deb rebuild, and that will recreate the package. Yeah, this is new. So please try this and report bugs to the BTS. Also cosmetic bugs, it's very rough still. And so finally, soon I hope we finally get this. But it's a bit rotten a bit, so we need to reset this up. There's 2 rebuilder tools we have had, this is one Frederic Perrier wrote, and there's another one from the Arch Linux people. They wrote, KPC YID wrote a rebuilder tool which can rebuild both Arch Linux and Debian packages. This is work for the next months. I think I'll skip this to have some time for Q&A. Because there's also more Debian successes, which are not so much known. We have the Docker images on Debian, Docker Debian Net. They are reproducible since 2 years, if I remember correctly. And since very recently, the live images on CD image Debian.org are also reproducible today. And the Debian installer, in theory, is reproducible, but we can only test it during development, so then it became not reproducible for the bookform release. But we hope that for Trixie, they will also be reproducible. And to give a quick overview, there's other project. Tails is reproducible since 5 years. Tails only produces one ISO, and that is reproducible. Debian has the 30,000 packages, so it's more complicated. Arch Linux has rebuilders, is reproducible in the same percentage. SUSE now plans to do a new spin, I think is their term, for reproducible spin. They have announced it this year. NixOS and Geeks are aimed to be reproducible. Yocto, which is an embedded build system, does reproducible images. F-Droid has some reproducible apps as well. Alpine has basic support. BSDs are reproducible for NetBSD. The base system is reproducible on 20 architectures now. And it seems that Fedora, Red Hat, and Ubuntu are not interested, which is not really true. Fedora enabled clamping of mtime packages using source date epoch this year, or last year. So Fedora aims to have reproducible builds as well. Red Hat is a bit more skeptical because of their distribution model. From Ubuntu, I've heard rumors. I will not go into detail here. So there's progress. And today, many projects support reproducible builds. It's still a bit unclear what it means, how it's enforced, but we have gotten there that the technology is there. And I call it reproducible in theory or CI. And this is a massive success, because it was thought impossible 10 years ago. And so in theory, we are almost done. And in practice, we have shown that reproducible builds can be done in theory. So we are not there yet. For Debian, we now need to set up rebuilders, and we need to store the results. We need to have defined criteria, like if we have 2 or 3 rebuilders and they disagree, and we need user tools, what to do with this. And we have those last 1% packages. Debian misses 2%, so about 600 source packages are still need work. But, yeah. And this is again from 2014, because they also realized that we need infrastructure and not only in theory. But we get there that we now can create the infrastructure. Yeah, so many projects have adopted this, and this is huge success. And the next step is to finish this 1%, and there's probably also new challenges like profile-guided optimization. Sometimes signed binaries or secure boot was difficult, and there might be other new fancy technology which might make it difficult. And we need to create the infrastructure, processes, and tools to use these results. And we need project-level consensus to do this, and commitment. To say, okay, we have yet now policy, and if the package is not reproducible, it gets kicked out. That is something the project needs to decide. So this was it from me. There's a bit of time of question. Thank you, and all contributors.
Hello. So, regarding OpenBSD, you mentioned that it is reproducible. However, I also know that they relink their libc and their SSH server every time their system boots. So that poses an interesting question. So, how does it matter that the build artifact is reproducible when the binary on the end user system is deliberately made different every time the system boots?
Well, if there's not, there's several aspects to this. You can have build time randomization and runtime randomization. And build time randomization is not helpful because you distribute the build. So if you have runtime randomization of the libraries, that is more useful. But OpenBSD is the one outsider in the project, was not listed there for a reason, because OpenBSD did not, they say it's not useful. NetBSD, FreeBSD, ElectroBSD say it's useful. The OpenBSD people are like, well, our build system is secure, we don't need this. So maybe this has changed, but the last I heard from OpenBSD was that they are the one project which disagrees.
So you have a timeline, and it says there are some policy violations planned, and then fewer of them planned, and then 0. So can you please go into more details about? So are you thinking about specific violations which will be fixed sooner or later? Or is it about packages?
I didn't get the beginning of the question.
There was a timeline table with the releases, and it said something like 40 violations are expected to be kept in like Trixie +1. Are there some specific violations, or is it just a projection of numbers?
Those, in that idea, those were packages which are unreproducible, but we need them. When we have changed policy, that we say, okay, all packages must be reproducible, but then there is whatever the kernel or something, and we cannot kick out the kernel. And we could say, okay, who needs GNOME? Everybody can use KDE, but no, we cannot kick out GNOME. So then we'll need some whitelists in the beginning, I think.
Hello, thank you for your talk. I have two small related questions. One is, do you know which repository are they in the non-reproducible packages in main or contrib? And over the time, there was always this small bit of non-reproducible packages. Are they mostly the same packages that don't ever move, or were there new ones coming in and old ones repairing, so to say?
No, it's the same packages. It's not packages which have become reproducible usually stay reproducible. It's very rare that a new upstream version introduces unreproducibility, and it's even more rare that the Debian packages introduces this. But the packages which are unreproducible, there's 22 source packages out of the most PopCon 1337 most popular. These are unreproducible. And build essential by now is reproducible, and required is reproducible, but build essential depends, which is 5,000 packages. And out of these are the 96 packages for build essential depends, which are unreproducible. But when we have fixed those, this is like there's 600 left. So it fits on a screen now. But it's still a bit of work.
So one set of packages, or one set of artifacts that is not currently reproducible in Debian is the cloud images. So if anybody out here is interested in working with the cloud team and making those images reproducible, come to the CloudBoff later this week. I think it's on Friday, or come talk to me sometime.
Awesome. I'll come to you after the talk.
So, unfortunately, the time is now over. Holger will still be here for your questions. See you in the next talk.
Thank you.